Hi, boys and girls. How's it going? We're on chapter 13, lesson 3, and this lesson is called Area of Combined Rectangles. All right, now combined, kind of, put together. When you combine things, you put them together. Of course, you know what rectangles are, right? So when we look at number 4, the directions say, find the area of the combined rectangles. All right, so I want you to, before we start this, think about what you already know about rectangles. So right next to this one, I'm going to draw a rectangle that doesn't have a little chunk out. Okay, so right here on this side, it's 9 feet long, right? Now, guys, you know a lot about rectangles, don't you? So you know that if this side is 9 feet long, how long is this side of the rectangle? That's right. It's also 9 feet long. That's exactly right. And what else do you know? Well, let's see here. This is 6 feet right there. That's, if you know that that's 6 feet, this side is also 6 feet. The sides that are parallel are equal in length when you're dealing with rectangles. Okay? Parallel sides, they're both 9 feet in rectangles. Parallel sides, they're both 6 feet in this rectangle. Okay? So the strategy in number 4 to find the area is, emphasis on the word combined there, is to kind of make this one rectangle into 2 rectangles. So now we kind of have 2 rectangles we're dealing with, right? Let's think about area also for a second. Area is the length times the width. Do you remember we were talking about arrays yesterday? Or whenever you watched the last video, maybe not yesterday. Remember you learned about arrays when you were in 3rd grade? 3 rows of 4, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3 rows of 4 equals 12. That's really what area is. You're counting how many rows of squares. So for number 4, it's square feet. Okay, so let's look at these 2 rectangles. There's one at the top and one at the bottom. So I'm going to look at the big one on the bottom first, okay? So if area is length times width, let's see. There is one of the dimensions, 6 times, let's see. There we go. The length is 7, okay? You agree with me? 7 rows of 6, okay? So 6 times 7 is, let's see, 5 times 7 is 35. 6 times 7 is another set of 7, 42. Okay, so I'm going to write 42 right inside this rectangle. Now I want you to think about why I didn't use the 9. Why did I use the 7 instead of the 9? Well, because the 9 is the distance all the way up. Remember when we drew the rectangle over here? That 9 is from top to bottom. That's not a dimension of this rectangle. Okay? That rectangle is 6 feet by 7 feet, 42 square feet. So now we have this guy up here. We know one of the dimensions, it's 4 feet long, but we don't know the width of this rectangle. We know it's 4 feet long, but we don't know how wide it is. Okay, so remember earlier I was telling you how much you knew about rectangles, right? So let's just pretend that this was a whole rectangle. If 7 feet is from here to here, right? That's 7 feet. How much longer does this side have to be to make 9 feet? Look back over here at this rectangle. This is 9 feet, so this is 9 feet, right? So this is 9 feet, so this is 9 feet. Here are 7 of those feet, plus how many more to make the 9? 7, 8, 9. 2. So, I'll use a different color. 2 feet. So that little square on the top has 4 feet in length times 2 feet in width. It's basically 2 rows of 4 feet. Okay, that's 8. Okay, so now we have to combine those 2 rectangles areas to get the area of that one rectangle. All right, I'll do that down here. 42 plus 8, which is the area of that small rectangle on top. Okay, 8 plus 2 is 10. 4 plus 1 is 5. So the area of this combined rectangle is, I'm going to have to write it down low here, 50 square feet. All right, guys, use what you know about the sides of rectangles to figure out the missing length or width, okay? All right, let's try another one, guys. All right, so number 5, I'm going to do this. Okay, what do you think of that? So let's start with the big one more time. So there are 3 numbers around here, right? What is the length and the width of this figure? Is it 16 by 13? What is it? Is it 12 by 16? Is it 13 by 12? What about that 6 over there? Well, think about the length and the width only of this figure right here. Okay? So the length is, well, let's do right here, 13. Now, what about the width? Is the width 16 or is it 12? I bet you already know, don't you, boys and girls? 16 is all the way across the bottom of this figure. That 16 goes from here to here. And this is not part of that big rectangle, is it? So the dimensions of this rectangle are 13 by 12, right? Because that 12 is part of a large rectangle, not part of this little guy right there. All right, so 13 by 12, 13 rows of 12 little square centimeters. 2 times 3 is 6. 2 times 1 is 2. Got a 0 placeholder. 1 times 3 is 3. 1 times 1 is 1. Okay, 6 plus 0 is 6. 3 plus 2 is 5. And then 1 in the hundreds place. So guys, I'm going to write 156 square centimeters. Okay, now we're not finished yet. We have this little guy over here, don't we? All right, so we are looking at this. We have one dimension, so it's 6 feet long. But what is the width of this? Well, remember what you know about rectangles. You know that this, and if I drew that all the way out, that this and this, those 2 parallel sides, would be equal, right? From here to here, I'm going to rewrite it, is 12 centimeters. It says it right there, but I've written on it a billion times. So 12 is from here to here, right? So how much is it from here to here? Well, look down here at that parallel line. From there to there is the same as up here. It's 12. So how much more do I need to make this line of 16? 12, 13, 14, 15, 16. That is 4 centimeters. 4 centimeters plus 12 centimeters is 16, right? So the dimension, the width of this little rectangle is 4 centimeters. So it's 6 rows of 4 centimeters. All right, what's 6 times 4? You know that one. 24. So 24. So what do we do now? Combine the two areas of those rectangles. 156 square centimeters times, whoa, I just said times. We're not multiplying because we don't have 156 sets of 24, do we? No. We're just combining those two rectangles. Good gravy. Okay. 6 plus 4 is 10. And then 5, 6, 7, 8. And then 1 in the hundreds place. Okay. So what is the area of those, what is the combined area of those two rectangles? It's supposed to be written right there, but I'll write it down here. 180 square centimeters. Awesome. Guys, you're really getting the hang of this, okay? Just remember everything you know about rectangles. You got this. All right, now for this one down here, I copied the whole thing onto this slide, but I'm only going to do one of these problems, okay? I'm going to do number 7, and you're on your own for number 8. You can do it though. It says use the diagram for 7 through 8. Nadia makes the diagram below to represent the counter space she wants to build in her craft room. So boys and girls, this is a drawing as if you're looking down from the ceiling onto the counters. So she has counters all around the edge of the craft room. Okay, so we have like an overhead view of the counters. So what does number 7 say? What is the area of the space that Nadia has shown for scrapbooking? All right, let's see here. This space doesn't have any label, does it? There's scrapbooking. There's the area for painting. Okay. All right, so we only want to find out the area for the scrapbooking. So I see one dimension of that rectangle. Do you see the rectangle we're working with? Right here. Okay, so the length is 13. Now remember, area is the length times the width, right? So the length is 13 times, and we don't have a label for the width, do we, boys and girls? All right, we got to take a look at this situation, don't we, guys? All right, let's look at what we know. We know that that's 15 feet. We know that that is 9 feet. Okay, and we know that that is 11 feet. So what do you think? Which of these is going to help us figure out the width of the scrapbooking counter? Right here. We need to figure out that. What do you think, guys? I'm looking at, that's 15, right? From here down to here, it's a total of 15. And right here next to it, they have 11. Oh, I just drew right over the 11. I'll write it again. 11 feet. Sorry about that. Okay, so we need to figure out this distance, right? So we know that from here to here, it's 11 because it's right here next to that one that's labeled 11 feet. So if this is 11 from here to here, how much is it from here to here? Well, remember that this whole line is 15 feet long. So we have 11 and how many more to get to 15? Well, let's see, 11, 12, 13, 14, 15. 4 more feet. 11 plus 4 is 15 feet. So the dimensions of her scrapbooking counter, length 13, width 4 feet. Okay? Length times width, so let's rewrite this up here. 13 times 4, 4 times 3 is 12. 4 times 1 is 4, plus 1 more is 5. So the area of space that Nadia has shown for scrapbooking is 52 square feet. All right? So guys, you do this one on your own. What is the area of space she has shown for painting? Okay, so right there, that painting, how much area does that have? All right, you can do it. Let's keep going. Turn it over to the back. Okay, this is number 2. Marquise, let's say, is redecorating his bedroom. Redecorating, that means he's decorating it again, right? What could Marquise use the area formula to find? Okay, the area formula, all right, remember area equals length times width. Okay, let's see. How much space should be in a storage box? Okay, now when I think of filling things, remember I did this V? And I did like water, right? But you can also put cubes in there, right? Filling things, okay? What's that V for? The V is for volume. You fill things with volume, so that's not area. What length of wood is needed for a shelf? Okay, how long a piece of wood is? Length. Length, that just reminds me of like a line, a straight line. That doesn't make me think of area, which would be, you know, a big space, covering space, right? All right, so, well, I don't think B is right either. C, the amount of paint needed to cover a wall. When I think of a wall, all right, think of a wall, look at a wall. You must be near a wall, right? Is it important to know the area of the wall before you go and buy the paint? Well, what if you had a giant wall like one in the auditorium of your school or in your classroom, and you brought home a little teeny can of paint? That would not be a good match, would it? So area and a wall being painted, I think that might be the winner, but let's check D. How much water will fill up his new aquarium? Well, you know what that makes me think of again, filling things up, right? Whoop, 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 especially with water. Volume, whoop. Let's fill up that volume V. So it's definitely not D either, is it? So the paint needed to cover the wall, right? So let's say I'm painting this slide right here. The whole thing is covered with paint. That is something you definitely need to know area for. Okay, awesome job, guys. Now we're on to the review question. So this is number 4 on the bottom of the back. Chapter 5, lesson 4. We're going way back. Drew purchased 3 books for $24. The cost of each book was a multiple of 4. Which of the following could be the prices of the 3 books? Okay, let me go back and reread this. So he got 3 books for $24. The cost of each book was a multiple of 4. Okay, remember multiples, guys? Multiple, multiply. What's 4 times 1? We're going to multiply 4 to get the multiples. 4 times 2, 8's a multiple. 4 times 3, 12 is a multiple. Okay? Right? You got that? Remember multiple, you multiply the number to get the multiples. Multiple, multiply. All right, let's look at our choices. A. Well, I know that 10 is not a multiple of 4, right? 4 is, but not 10 or 10. Bye-bye. B. 4, 8, 12. 4, 8, 12. Uh-huh. That might be a winner. C. 5, 8, 11. Let's look over at the list. No, not 5. 8, yeah. Not 11. D. 3, 7, 14. None. None of the above on that one. Okay? So the multiples of 4 are right here in B. 4, 8, 12. Fantastic. You guys are amazing. Have a great night. Finish up your homework, and I'll see you soon.